In this lesson, we're going to look at mixed numbers. It's the first of two lessons on mixed numbers. So, a mixed number is a number that contains a whole number and a fraction, right? So, whole number, fraction, there's the whole number 2 in this example, and the fraction part is 3/5. But the most important thing you have to keep in mind is that you think of it like it's one big single number. So it's not two numbers or three numbers, it's one thing. It's 2 and 3/5 in this case. And of course, they could be thought of, that's the same as 2.6, right? And you know that 2.6 is just one number. So I want you to think of mixed numbers the same way. 2 and 3/5, single number. Compare that to an improper fraction. That's a fraction where the numerator is greater than the denominator. So, for example, you've got 13 over 5. I can switch something from a mixed number to an improper fraction using the following technique. So if I start with 2 and 3/5, if I take the whole number, the 2, multiply it by the denominator, and then add the numerator, so 2 times 5 plus 3, and put it over the same denominator. 2 times 5 is 10, plus 3 is 13, and so that's 13/5, which is exactly the same as what I've got down below as the improper fraction. So that's equivalent. 2 and 3/5 is equivalent to 13/5. If I want to work backwards and change 13/5 into a mixed number, what I need to do is I need to divide 13 by 5 in this case, and it goes in 2 times, and 2 times 5 is 10, so there's a remainder of 3. That's what goes in the numerator of the fraction part, and it's 2 and 3/5. So you can add or subtract mixed numbers by dealing with the whole number and the fraction part separately, or by changing the mixed numbers into improper fractions first. So the two different methods. The first method can be more complex for subtracting than it is for adding. To be honest, I always prefer to change things to an improper fraction. Almost always, I'd say. 99% of the time, if I had to guess. You can do either method as long as it works. However, you also need to be aware that if you're multiplying or dividing, you're going to have to use improper fractions. So I guess what I'm getting at is I'm going to show you both methods, but I'm definitely encouraging you to take the improper method approach, method to improper fractions. Okay, so the first one where we add separate parts. So if I want to take this number here and add it together, so I can add the whole numbers together, I can add the fractions together, so I'm just moving the different parts around. So I am separating these numbers into parts, and then we know that 1 plus 5 is 6. We need to get a common denominator for the fraction part, right? So we need a common denominator for that. So we can always get a common denominator if we multiply denominators together, like 3 times 4 gives us 12. It won't always give us the lowest common denominator, but in this case 12 is the lowest common denominator. So if I want to change both of these fractions into fractions with denominators of 12, I need to multiply the top and bottom of the first one by 4. 4 times 2 is 8, 4 times 3 is 12. The second fraction, the 3/4, I'm going to need to multiply the top and bottom by 3. 3 times 3 is 9, 3 times 4 is 12. That's how I get my common denominators. Then I add the fractions together. Remember, when we add fractions, we only add the numerators. So we'd have 17 over 12. And finally, I would not write this as 6 and 17/12 because now I've got a whole number mixed with an improper fraction, which is no good. So 12 goes into 17 one time with 5 left over. So I'd write that as 5/12. Putting it all together, I get 7 and 5/12. So that works. Not my favorite way, but it'll work. All right. Here's what I consider to be better with the improper fraction method. So change both the numbers into improper fractions. So as I showed above, I multiply 1 times 3 and add 2. So my first fraction turns into 5/3. My second fraction, I multiply 5 times 4 and add 3, and I get 23 on the top. So just change them into improper fractions. Still need to get a common denominator, so we're still going to multiply the first fraction by 4, top and bottom. 4 times 5 is 20, and I get 20 over 12. Going to multiply the second fraction by 3, top and bottom, so 23 times 3 is 69 over 12. And then I add the numerators as I did before, and I've got 89 over 12. And I could leave it as an improper fraction, or, again, I could change it back to a mixed fraction. 12 goes into 89 7 times, with 5 left over, so I could write it as 7 and 5/12. Again, that's a single number. Notice how that's the exact same answer as I got for using method 1, because, of course, the answers have to be the same. If I want to subtract, exact same thing. It's a bit harder for subtraction because sometimes we have to play around with the numbers we've got. But if I want to combine them, I could do 3 minus 1 plus 1/3 minus 5/6. Again, already looking a bit confusing to me, but let's carry it through. So 3 minus 1 is 2. And for the common denominator, I don't need to multiply the 3 and the 6 together because 3 goes into 6. So I could use 6 as my common denominator. So all I have to do to change the first fraction so that it's out of 6 is multiply the top and bottom by 2. So I got 2/6 minus 5/6. But then we run into the problem that if I try to subtract 5/6 from 2/6, I'm going to end up with a negative number, which is going to be really weird in this fraction. What I need to do is I need to borrow one of my whole numbers. So in other words, if I reduce my whole numbers, my 2 by 1, and then change the other 1 that I've taken away from it into 6/6, right? 1 plus 6/6 is the same as 1 plus 1, which is 2. So I haven't really done anything other than change the format. And then I can combine everything together. I could have, for my numerators, I'd have 6 plus 2 minus 5. Now it'll work out because 6 plus 2 minus 5 equals 3, so it's 1 3/6, and then I could reduce that to 1 1/2. So it works, but again, not my favorite. Let's try it with improper fractions. So change the first fraction into an improper fraction. 3 times 3 is 9, plus 1 is 10 over 3. The second fraction, 1 times 6 plus 5 is 11 over 6. Get a common denominator. Again, 6 would work, so if I multiply top and bottom of the first fraction by 2, I get 20 over 6. That shouldn't be an equal sign, should it? That should be minus. Subtract, I get 9 over 6. And again, well, I should always reduce. I know that 3 goes into the top and the bottom, and so I can divide the top by 3, I get 3. Divide the bottom by 3, I get 2. And again, I could change it back into a mixed fraction. 2 goes into 3 once with 1 left over, so that goes in the numerator. And again, if you compare this to method 1, I got the same answer. So either way works in this case. Measurements of length, this is just another example. Measurements of length by carpenters, plumbers, and electricians still use imperial system, yards, feet, inches. So just skimming ahead to see what we got there. Okay, yards, feet, inches, yes. This leads to calculations involving mixed numbers if we're using imperial measurements often. If a 1.5 inch nail is hammered through a 2.5 inch nail through a 2 3/8 inch board into a beam, how far into the beam does it go? So imagine we're looking at something from the side. Here's the beam, right? It's up and down. It's a post. Someone puts a board on the end, so we're looking at the end of this board and drives a nail into it. So I'll do the nail in different colors. So we got this nail, and it's going in. It's going to go right through the wood into the beam. We want to find how far how far into the beam it goes. So whatever's left over. So it's the difference between the thickness of the wood and the nail. So the answer is going to be 2.5 minus the 1 3/8, the difference between them. So using my preferred method, improper fractions, I would change the first fraction to 2 times 2 plus 1 is 5. over 2 minus 1 times 8 plus 3 is 11 over 8. Get a common denominator. 2 goes into 8, so if I multiply the first fraction top and bottom by 4, I'll get 20 over 8 minus 11 over 8. And then I subtract, I've got 9 over 8, which in this case probably would make sense to switch back to a mixed fraction. 8 goes into 9 one time with 1 left over, so it would be 1 1/8 inches. Okay. Multiplying and dividing mixed numbers, some similarities, but we have to make them. One thing that we can't do is we do have to change things from mixed fractions into improper fractions. So here's another good reason for using improper fractions. Since you're going to have to do it anyway for multiplying and dividing, you might as well just be consistent and do it for all of your fraction needs. So we do that, but there's a few other differences. We don't need a common denominator, all right? No common denominator. Please be very clear on that. People who get common denominators for multiplication and division questions are making it infinitely harder on themselves because they're making the numbers bigger for no good reason. Don't get a common denominator for multiplying or dividing. So, aside from changing it to improper and then just multiplying the top times the top and the bottom times the bottom, we're good to go. So let's try the first one. So 2 times 2 is 4, plus 1 is 5 over 2. 3 times 3 is 9, plus 1 is 10 over 3. If I multiply the top times the top, I get 50, and bottom times bottom gives me 6. Now I can reduce this. In fact, I need to reduce this because it's not considered 100% correct until we've got it in lowest form. Since they're both even numbers, I know I can divide the top and bottom by 2, and I'd get 25 over 3. And I would be inclined to leave it like that, but if you want to change it to a mixed fraction, 3 goes into 25 8 times with 1 left over, so it'd be the same as 8 1/3. If I'm multiplying a negative number times a positive number, well, there's a couple things going on. First of all, I've got a whole number, so I can think of that as a fraction. So just when we're working with a fraction, try to think of everything like a fraction. So think of this like it's a fraction as well. But also put the negative sign on top. That is important. We need to have a place to put the negative sign. As you know, it could go on top, it could go in front of the whole fraction, or it could go on the bottom. We're going to always put it on top for consistency. I'm going to change the other fraction to an improper fraction. 4 times 5 is 20, plus 1 is 21. I'm going to get I was going to get a common denominator until I caught myself and remembered, no, we're doing multiplication. So I won't get a common denominator, I'll just multiply. Negative 3 times 21 is negative 69 over 5. And again, if I want to change it to a mixed number, 5 goes into 69 13 times with 4 left over. So it's 13 4/5, and just put the negative sign out in front of the whole number. So I stick it way out in front. So I only put one negative sign there out front. Never, never, never should I ever see a negative sign in the fraction like there. Shouldn't see one there. Should never see one at the bottom. Never. If the number's negative, it goes out front, okay? Dividing is exactly the same as multiplying. The only difference is that before we multiply, well, we are going to multiply, but what we do is we flip the second fraction upside down and change our divide to a multiply. Otherwise, it's exactly the same. So let's just do an example to make it clear. 3 times 4 is 12, plus 1 is 13 over 4. Divided by 2 times 8 is 16, plus 1 is 17 over 8. So now I'm going to change that to divide to a multiply. The first fraction doesn't change at all, but the second one I flip upside down. So I put 8 over 17, and I change that to divide to a multiply. And again, I could just multiply top times top and bottom times bottom, and you won't be wrong, but you'll definitely get big numbers which you have to reduce. Here's another pro math tip that I really think that you should try your best to remember, is look to see if there's anything on the top or bottom that you can reduce. So this only works for multiplying. It doesn't work for adding or subtracting or dividing, but if you've got it down to this stage where it's multiplying, then you can try to reduce anything on the top of a fraction with anything on the bottom. For example, I see that 4 goes into itself and 4 goes into 8. So I can divide the bottom by 4, and I just get 1. Divide the top by 4, I just get 2. And now I've got smaller numbers. I don't see anything else that reduces, so I do 13 times 2 is 26. 1 times 17 is 17. And now I don't need to reduce later with bigger numbers. It's already as low as it can go. And as an improper fraction, 17 goes into 26 once with 9 left over, so I could write it like that. Here's another example, exact same idea. 5 times 3 is 15, plus 1 is 16, over 3, divided by 2 times 9 is 18, plus 2 is 20, over 9. Flip the second fraction and change it to a multiplication, so it's 9 times 9 over 20. I see something I can reduce. 3 goes into itself once, and 9 3 times. I see something else I can do. 4 goes into 16 4 times, and 20 5 times. So I'm going to be able to keep my numbers much smaller. 4 times 3 is 12. 1 times 5 is 5. And so there is a pre-reduced fraction. As a mixed fraction, 5 goes into 12 twice with 2 left over. Okay, so I went through this quick. I always try to on my videos to keep them short, but if there's anything that went by you too quick, please go back and check it out again. It's all there. And, of course, as always, practice with the practice questions. Good luck.